Hello all. Today we will discuss about the building performance. Earlier we have discussed about the building automation system. So building performance generally is building function in terms of quality, resource saving and workload capacity. So we analyze the performance of building in terms of quality and resource saving, how we are saving the resources and workload capacity and capacity for services and what all other loads we need to cater. So we will discuss about the terms and terminology in building performance, like aspects. So building performance aspects are energy efficiency, thermal comfort, indoor air quality, and daylighting. So these terms is our main aspects, and we calculate uh, for these terms and then we analyze the building performance. Uh, so the subdomains for building performance are thermal simulation, lighting simulation, acoustical simulation, and airflow simulation. These are the subdomains. Thermal simulation, like lighting simulation will come under the lighting, and acoustical simulation, airflow simulation will come in thermal comfort. So basically, these are the simulations, and with the help of software and building management system and building automation system, we do the analysis for the performance. Then, what are the objective for building performance simulation and how we do the building performance? Like objective of building performance simulation is calculating the performance aspect under these criteria. So the, the aspect which we have discussed, like daylighting and thermal comfort, those will be assessed under these criteria: design, construction, operation, and control of building. At the stage of design, what we are giving the data: construction stage, operation, and control of building. So all other stages uh, form the collective data starting from design and operations. So, what are the various necessary input data for a whole building simulation? So, we need some specific set of input data for a whole building simulation. If we want to up automation system and management system and whole building simulation, we need some data, and which is called like local data in terms of climate, site, inside location and orientation of the building. These are the generally data associated with the building, how the ground properties is there, surrounding building, geometry, building key shape, zone geometry, then envelope, type of material used in construction, window shading, infiltration and openings, like internal gains, light, equipment and occupant, including schedule for operation and occupancy. Internal gains, heat through occupancy. These data is also needed for whole building simulation. Ventilation system, room units, and plant and control. So these are the necessary information we need to have before uh, we calculate and do a analysis for the building performance, how the existing building uh, is performing. We take that data of uh, calculating calculating load or design load and air conditionings, lighting load, and various data. So sometimes those data we can use to similar building which are going to be constructed somewhere. So we know that how how many occupants are and how much load is that building needed in future, and past building experience we can do better judgment about the calculations and about the sizing of machinery. That's why the building performance, what input we are giving and what output we are receiving. So for that, there are some key performance indicator how we analyze the performance of building. So there are some indicator like in temperature trends, by temperature trend in zones or surfaces in construction layer, or hot or cold water supply, or in double glass facades. Different zones, we take a temperature trend, how with which temperature is needed at which zone, and then comfort indicator, uh, radiant temperature asymmetry, CO2 concentration, relative humidity. So these are basically the parameters for analyzing the performance, like heat balance, load profile, energy demand, daylight availability. So these are the simulations tools and used to form a data for the performance analysis, and that is sometimes called total building performance, TBP. And by building performance, we can sum up some points like we have more savings in practical if we use simulation system and calculate the necessary data for our building. So we can save our money and our resources by a particular simulation system and uh, necessary data of for our building if we have. So we use local data as an input and able to give a design model. We also accurate load calculations and precise machinery size. So these are some conclusion by those factor to include in our uh, performance and in our simulation software. So we get accurate things, accurate size, accurate uh, things to go in a service system. So even if we design a building in an efficient way and we show more savings in our document, but practically the performance is different when building comes operational. So when building is in operation, the gap are very high. What we predicted before, that this building consume this much of energy, this building consume will need this much of load in HVAC, in lighting and in heating, but practically that doesn't happen because the actual data and actual calculations are missing. So by using existing building data, we can design system for similar building, but we have to consider local condition. And again, if we are using the existing building data, but local conditions we are ignoring, then our performance will be not that. So what are the latest things like data management, help in operation, and facility management in a building, and BMS. And effective data management strategy becomes essential for building. So, if effective management strategy is there and data management is there for operations and facility management, so we can operate our building at present well, and we can have some uh, future predictions based on our past, and we can uh, have we can use that data for doing our load and our things in systems like in HVAC and for our thermal comfort. So like total building performance, we can take these 3 points like performance mandates, limit of accessibility, terms of evaluation. So Performance mandate, all other factor which we have discussed here before, and spatial, thermal, acoustical, visual, building integrity, indoor air quality. These we can take a mandate, mandatory and for performance aspect. So physiological, psychological, sociological, economics, under these terms, and then terms of evaluation, suitability and reliability, flexibility, and we can sum up like high performance building by this diagram. Thank you.